Hi, I'm Ryan and you're watching my YouTube series on functional programming. If you're enjoying this series, please subscribe, like, or let me know in the comments. In this episode, we are going to introduce container types while performing function composition. And as a result of that, we will end up defining a new map utility to facilitate this process. So let's see an example. Over here, I have four functions. The first function read file accepts a file name and hypothetically it returns this data from a file system. But in our case, I have encoded it over here as mock data and it contains a JSON array. I have this function here getJSON which simply parses any data passed to it. I have another function which gives you the length of its argument and another function print which just prints whatever is passed to it. What I want to do here is I want to take the contents of a file, in this case just a mock file name, and I want to print the length of the array in the file. So if I were to do this using a regular composition, I would simply say pipe, pass it the file name, let's say f or file. It's irrelevant at this point because my data is mocked. So I want to first do read file, then I want to pass the output of read file to get JSON, then I want to pass the output of get JSON to get length, and eventually I want to pass it to print. Now if I run this code, I get the value 2. All is good. But what happens when there's an error? Like there's a formatting error in my JSON. Now if I try to run this code, everything blows up. And that's because it is still trying to run the other functions in the composition chain while there has been an error. And this is why we're going to introduce a container type to encapsulate this duality. So over here, we're going to say when you receive the contents of the file, return an either.from try. From try because we're getting an error. The JSON parse is giving us an error. So we want to return get JSON from contents. So now if we try to run this code, let's see what happens. We get undefined. That is fine, but at least our code did not blow up, right? So now let's fix this and see what happens. You would expect 2 to show up, but that didn't happen, right? For some reason, it's still giving you undefined. Why is that the case? It's because now that you're returning a container type, getLength does not know how to deal with it, because getLength was expecting an array which has a length property, whereas an either does not have a length property. So now there's a conflict because your container expects primitive types, whereas you're returning a container type or a functor. So all these containers are functors. I'm just going to call them functors hereafter. So I'm returning a functor over here, but my functions expect a primitive type. In order to solve this problem, we are going to create a new function called map. The way we're going to define it is we're going to say const map is equal to curry, which takes a function, takes a functor, and runs f.map function. So let's try to understand what's happening here. Let's say we have an either e, or let's call it either. What we actually want to do is we want to either.map on getLength, because we want to take the value that is stored in the either and map it on the getLength function. This is what we want to do. So we have created a curried function over here, and what it does is, I'm going to define it left to right, right to left. I'm going to say map get length either. So this is equivalent to writing this because I have a map function like this. So now that I have a curried version that is expecting an either in order to perform this operation, you can simply replace it over here. And that lets me pass the value of an either to the getLength function. But notice an either over here is not going to solve a problem. So let's try to run this code and see what happens. We have a write of data 2, but that's not what we want. We wanted the value 2. So what's happening? Understand that when you introduce an either or a container type or a functor in a composition chain, you will always have a container type throughout the rest of the chain. Why is that the case? Because notice what you're returning here. You're returning f.map function. And what is this? This is a container, or this is a functor. Why do you think so? Because remember, you can always do f.map again and pass in f2 and .map to pass in f3, and that's because each subsequent invocation of map returns a functor. So the output of getLength again gets wrapped inside of an either, or the original functor from which it got its value. So if you want to get that value out of it, you're going to have to map on it again. Oops. Okay, so now that you mapped on it, now let's run the code and see what happens. Now we get the value 2. So let's clear our console and try to see what happens when there's an error. Nothing runs. In fact, something ran, but we could not complete the chain or complete the whole composition because there was an error early on, and we eventually got a left. And once you have a left, you cannot map on it. But the moment you have a right, you can map on it. So the point to remember here is whenever you have a container type or a functor introduced, you will always have to use the map utility to wrap the subsequent functions in the composition chain. And that's because once a functor, always a functor. That's my rule to remember. Once a functor, always a functor. And hereafter, you'll always have to use the map utility to extract the value of the functor and run your regular functions on them. And well, yeah, that's about it for this video. I hope you found it useful. And stay tuned for new stuff in the next video. Thanks for watching.